All right, let's jump right in. Today we're getting into the nitty-gritty of two of the most foundational algorithms in all of system design, round robin and least connections. Now these are the invisible traffic cops that literally keep the internet from falling apart. And by the end of this, you'll know exactly how they work, their pros and cons, and most importantly, when you should use each one.
So just imagine for a second, your app, your website, whatever it is, it goes viral. Suddenly you've got millions of people all trying to hit it at the exact same time. So how do you handle that? How do you keep the whole thing from just completely crashing and burning? Well, that is the exact problem that load balancing was invented to solve.
See, you can't just have one single, gigantic server. That's a huge risk, what we call a single point of failure. If it goes down, everything goes down. So instead, you have a whole fleet of servers, like a server farm. The load balancer is the traffic director that stands out front, and its one job is to smartly hand out all those incoming requests to the different servers so no single one gets buried in work.
Now the very first tool you'd probably reach for to direct all this traffic is called round robin. And I want you to think of it exactly like you're dealing a deck of cards to players sitting around a table. It's simple, it's predictable, and it's our starting point.
Okay, so here's the textbook definition. Round robin is what we call a deterministic algorithm. Now, don't let that fancy word scare you. All deterministic means here is that there's no real-time thinking involved. It just follows a fixed repeating list. It assigns each new connection to the next server in the cycle, period. It doesn't matter what's happening on those servers.
And the process is, well, it's about as simple as it gets. The first request comes in, it goes to server A. The second one, server B. Third, you guessed it, server C. And once it hits the end of the list, that fourth request just loops right back around to the start, to server A, one after another in a predictable circle.
And that simplicity leads us to round robin's greatest strength, its speed. It operates in what we call O of 1, or constant time. Put simply, that means it takes the exact same tiny amount of time to make a decision whether you have 3 servers or 3,000. It's incredibly fast because it doesn't have to think. All it has to do is point to the next name on its list.
But, and you knew there was a but coming, right? This idea of simple, perfect fairness, it has a hidden flaw. And it's a flaw that only shows up when things get messy, which, in the real world, they always do.
So this is the absolute key insight you have to remember. Round robin makes sure that every server gets a turn, but it has no idea, zero clue, how much work is involved in that turn. It's fair in assigning the tasks, but it's completely blind to the actual effort required to get them done.
Let's really see how this can break down. Imagine server A gets a monster request, like downloading a huge video file that's going to take a full 30 seconds to process. At the same time, servers B and C get tiny little requests that take milliseconds. They're done in the flash. But what does round robin do next? It sends the next request right back to poor old server A, who is still completely swamped with that video download. Meanwhile, servers B and C are just sitting there totally idle. You've created a traffic jam all by yourself.
And this is where our second algorithm comes in to save the day. Least connections is the smarter, more adaptive solution. Instead of just blindly dealing cards, it actually looks at the table to see who has the fewest cards. We'll call this the least full bucket approach.
So unlike round robin, least connections is a dynamic algorithm. And all that means is that it uses real-time information to make its choices. Before it sends out a new request, it asks a very simple, very logical question. Which one of you servers has the fewest jobs to do right now?
The logic here is just so intuitive. A new request shows up. The load balancer takes a quick peek at all the servers. It finds the one that has the fewest active requests, the fewest in-flight jobs, and boom, it sends the new request there. It's common sense, right? This naturally prevents any single server from getting buried.
Of course, all this extra intelligence isn't completely free. It comes at a tiny cost. The time complexity is O log n. Now this is still extremely fast, don't get me wrong, but it does mean that as you add more and more servers, the decision takes a tiny fraction of a second longer. That's because the balancer has to do a little bit of work to find the least busy server. It's a classic trade-off. You give up a tiny bit of raw speed for a whole lot more intelligence.
So now we have our two main contenders. One is lightning fast, but a little simple-minded. The other is really smart, but requires a bit more overhead. So which one do you choose? Well, let's put them head-to-head and find out.
And really, this boils it all down perfectly. Round robin is just a list keeper. Its entire logic is asking, whose turn is it next? That's it.
Least Connections, on the other hand, is asking a question about the present moment. Who is the least busy and ready for more work right now? Two totally different philosophies.
And here it is, the ultimate cheat sheet. If you're prepping for a system design interview, you might want to screenshot this slide. Round robin, O of one time, it's best for when all your requests are basically identical, and it's stateless. It doesn't have to remember anything. Its big weakness? It's completely oblivious to server load. Least Connections, O of login, perfect for mixed traffic, but it's stateful. It has to keep track of active connections, and that's its main complexity.
Now, if you really want to sound like a pro in that interview, you can bring up some of these advanced topics. Talk about sticky sessions, which can sometimes force traffic to one server and kind of defeat the whole purpose of least connections. Mention weighted versions of these algorithms, because what if your servers aren't all the same size? And always ask about health checks. I mean, what happens when a server just dies?
So, what's the final verdict? The big takeaway? It's a really practical rule of thumb. Start with the simplest thing that could possibly work, and that's almost always round robin. It's fast, it's easy. But the moment your traffic starts to get unpredictable, with requests of all different shapes and sizes, that is your signal. It's time to evolve to the smarter, more adaptive power of least connections.
And that kind of leads us to one final interesting thought. We've gone from a simple rotation to checking real-time load. But what's next? As our systems get even more complex and distributed across the entire globe, what other factors will the next generation of algorithms need to consider? Maybe network latency, or the physical location of the data, or even the cost of electricity in that data center. That's the ongoing challenge and what makes system design so fascinating.